You're well by the grace of Allah. Today I have come in front of you taking another video which is very important for your approximate examination for the candidate of 2022. And here you are noticing a very important question from your textbook which is written on my whiteboard, and I'm reading out the whole question. You can also consider it as a stimulus. 75 gram chlorine gas is mixed with 5 gram hydrogen gas, which is the limiting reactant here. And how the reactant hydrogen gas H2 will be left over at the end of the reaction. And now let me write down and let me solve it. Okay, I'm going to solve it. First of all, if we want to solve this math, then we will need the chemical equation of these happenings or occurrence. So let me write down the chemical reaction. First of all, here there are two reactants. Number one, chlorine. Number two, hydrogen. Both are gas. We know that every real gas is biatomic or diatomic. Okay? First of all, hydrogen gas plus chlorine gas. If they react with each other, then it will produce hydrochloric acid. But it is not balanced reaction. We'll have to balance it. It is a skeleton equation, chemical equation, so we'll have to balance it. As hydrogen has 2 atoms, chlorine has 2 atoms, then we'll have to equalize. We can use 2 in front of hydrochloric acid, then this chemical equation is now balanced. Okay. Now we are detecting the molecular mass of this reactant. Hydrogen, the atomic mass of hydrogen is 1 and the number of atoms is 2, so we can write 1 multiplied by 2 equal to 2. Chlorine, the atomic mass of chlorine is 35.5 into the atom number is 2, so we can write into 2, 71 gram per mole. Okay, now we are going to write this mathematical solution in unitary method. First of all, we will have to detect which one is limiting reagent here, so we can follow a method. This method is W by N divided by N. Here, for hydrogen, we can say W is the given weight, 5 gram for hydrogen, and the molecular mass of hydrogen is 2 gram, and the mole number of this hydrogen atom is 1, so we can write 2.5. Okay, chlorine is given here 75 gram, molecular mass is 71 and number of mole is 1, so we can, and here we will get 1.056. So here the least one is chlorine, so we have already detected the limiting reagent will be chlorine here. Okay, so let's start the writing. 2 gram hydrogen needs 71 gram chlorine gas for the reaction. Then 1 gram needs 71 by 2 gram chlorine for the reaction. Now we have 5 gram hydrogen, so we will use 5 gram hydrogen needs 71 into 5 divided by 2. Okay? If we complete the procedure, then the result will be 177.5. you can use a calculator to complete the procedure. Now we can detect that we need 177.5 gram chlorine gas, but we have only 75 gram chlorine. We need more chlorine to complete this chemical equation and chemical procedure. As we have less than 177.5, we will have only 75 gram chlorine. So we can say that here chlorine is the limiting reagent. Okay? So we need 177.5 minus 75 gram. So we will get 0.5. Okay, this is the answer. Now there is another question which is written on my whiteboard. How the reactant H2, I mean hydrogen gas, will be left over at the end of the reaction. Okay, let me delete it. Now if we want to solve the second one, then we'll have to write it reversely. Okay, write it reversely. 71 gram chlorine gas needs 2 gram hydrogen gas. Where do I get it? I get it from that question. 75 gram chlorine gas is mixed with 5 gram hydrogen. If we write the equation, then we will get 2 gram, 71 gram. So we got it from this. 1 gram chlorine is gas needs 2 gram by 71 hydrogen gas. Then 75 gram chlorine gas needs 2 into 75 by 71 hydrogen gas. So we will get 2.112 gram hydrogen gas. As we are given 5 gram, but the chemical equation needs 2.112 gram, so rest of 2.88 gram, rest of hydrogen gas, 5 minus 2.112, 2.88 gram hydrogen gas is now remaining here. So this is the answer. I think that all of you have understood it better in a better manner. Thank you for watching this. Okay, goodbye.